Hi, Connor. Can you hear me all right?
Yes, I can.
Perfect.
Is it going to be you and me today only?
What was that? Sorry.
Was it just going to be me and you today?
No, I think it's so Jason and I are both in the lab here, and then I think we should have at least one more person joining um, online. Sorry.
Okay.
Camera going here. There we go. All right. Yeah.
And was your flyer record able to make it this morning or no?
I sent him a message, and he said that he should be able to make it, so we might see him logging in as well. But I
Okay.
told him, worst case, he can watch the recording or set in, like you mentioned, on the reviews there on site.
Okay, that's perfectly fine.
Awesome.
So we will wait for your other teammate to join.
All right. Let's see. Let me shoot them a message and make sure that they're still planning on it.
Okay.
He only lives like 10 minutes away, so hopefully.
Have you guys done ground deployment test yet?
Yes, we have. We actually shifted over to black powder. I know there were some concerns with the CO2 system originally. We had some issues with it, substantial issues. So we swapped over to black powder for just ease of operation, and we're familiar with it. So
Okay.
yeah, I think it's gonna be too much trouble for us to operate CO2 at this point. We weren't familiar with how quickly the gas actually distributes. And
Yes.
just have massive leakage, so it's unable to pressurize the deployment chambers. So
Okay. And you guys were trying to build your own SRAD CO2 valves, correct?
no, so we went with the CD3 and CD4 systems from Rouse Tech, and
Okay.
it was going to be student developed because Rouse Tech wasn't selling any CO2 systems. And then I was on the phone with Fred from, where is he from? Wildman? Or one of those companies. And he was like, oh, by the way, he released this new system, the CD4. And I was like, okay, just get us 3 of those, and we have a CD3. So we went with COTS originally. So, but then we've swapped over to black powder recently, and we've had successful ejection charge tests on both sections. So
Very nice. Okay. Yeah, so definitely just play around more with CO2 with like scale size rockets of like competition rockets, or even make a second practice rocket to like learn more of other ways of doing rocketry.
of course.
And then hopefully next year is to have the CO2 system in your rocket next year.
Yeah, I hope so. Let's see, did we get a response from Jay? Yeah. If we want to, we can get rolling, and he'll be here, my guess is in the next 10 minutes, or if you want to wait, either way.
I don't think you get going. So just before we start, just want to let you guys know this meeting is not a scored meeting. This is just for safety of the competition and all spectators there. So no points will be affected on your final score competition for this meeting.
Perfect.
And before we start going over your rockets, just give a quick introduction of team name, team number, and pretty much a quick overview of your project.
Absolutely. Team number, that's going to be an issue. Let me figure that out.
150.
Is it 150? You said 158?
150.
150. Okay. Got it. I've put it into so many forms already. I should know it, but that's just one of the things that slips. Okay. So you said what team, what number, and what else?
Quick description of the rocket.
Oh, okay. So Wichita State Rocket Club, team number 150, and we're flying a 11-foot, 2-inch, 6-inch diameter, full fiberglass rocket flying an M2000, carrying a 9-pound payload.
Awesome. Okay, so what I would like to do is start from the nose cone and work our way down the rocket. So let's show me the nose cone.
Okay, we are primarily disassembled. Let's see. Can you see the other video feed? There should be 2 of them. There's one on a moving camera and the one that's static.
I see just your face.
Okay, got it. Let's see, disable that one and enable this one. Did that work at all?
No, I see the top of your hat and the ceiling.
Hey, there you go. That's the moving one. Okay, perfect. Let's see. So we have it fully disassembled right now, because we knew that you would want to see individual component parts. Is it better if I turn it sideways?
Yes.
Does it orient? Like that? Oh,
That looks a lot better.
okay,
Well,
perfect.
now, no.
Turn on the auto, or disable the rotation lock. Oh, it is disabled.
It is disabled. Teams is just awful. All right.
Yeah.
Okay, so our nose cone is actually probably where most of our complexity is. That's not like super common with the competition. Sure, you know, quite a bit of teams have active systems on their rockets at this type of competition. But we have these servo wheels, basically. These are just shaft extension hubs that go back into our servo bay on the inside.
Okay.
That's for our ACS. Jace is going to disconnect this bulkhead here. This is a recovery bulkhead on our nose cone. So it's a doubled up 1/8-inch bulkhead, the usual. I'm not sure. Let me grab a screwdriver. I didn't realize. If you're going to want us to pull the ACS and everything out, I'm going to just grab a screwdriver and pull that apart. Or Jace,
Okay.
quick. So, yeah. So if you look down in there, there's the servos.
Nice. Okay.
We can pull that full sled. The battery for it and the telemetry are farther up on the rod. So currently, the microcontroller is powered by. You're gonna have to reach in there for that one. It's not captive. Yeah, you'll have to reach up from the end. The microcontroller is currently powered by just a small form factor LiPo battery. It's not the cylindrical metal case that we plan to use for the competition, but we do have a bunch of 18650s that we're going to fit into battery clips and make our own battery pack for that. Currently, we have a 4-cell 18650 pack that we made that is inside the nose cone on the threaded rod. I know that some of the concerns with that might be the fact that they are battery clips that are oriented longitudinally on the rocket. And so the G-forces on the clips, luckily they're fairly tight. I don't know how much concern there is over a potential disconnect on a clip like that in flight. There's Jay. So.
Was the LiPo battery for your microprocessor recommended and supplied by the manufacturer?
Was it? No, I don't think so. I think it was just one that we had.
Then you will not be able to use that battery. Stated in the D tag, I believe section 8.20.
Absolutely, the issue with the form factor and material.
Yeah, we are doing that, or this became a new safety factor this year. After last year, we had multiple LiPo batteries explode inside the rocket when they came down ballistically, and teams decided to bring them back to base camp and leak all over the post-flight data recovery area.
Oh, okay, yeah, that would make sense.
Yes.
So we have 18650 batteries. Is that something that meets the form factor and material requirement for the D tag that says cylindrical metal case, right?
If it's a cylindrical lithium ion, that's perfectly fine.
Yeah, I believe
It can't be rectangular.
18650s are LiPo, right? Or lithium ion. Okay, perfect. Oh, view lobby. Someone's trying to get in. Oh, there he is. Hi, Dr. Klausmeyer. This is our flyer of record and one of our mentors.
Nice to meet you,
Morning.
Steve.
Glad you could make it. So we're going to get a screwdriver here in just a second and pop those servo hubs, hopefully. I don't know why we don't have that screwdriver openly accessible. We just used it.
You're
That's
perfectly
that-
fine.
That's why it's not openly available, is because we just use it. It got sat down somewhere.
So is the whole entire rocket fiberglass, you said?
Yes, sir, other than the fins. So we can flip. Oh, that's not the right button. There we go. So the fins are carbon fiber, and we did structural testing on them here at NIAR, and got the modulus of rigidity that's needed to do the fin flutter calculations. Yeah, modulus of
Okay.
rigidity, mod, same thing. Yeah, so currently we have some aesthetic fillets on it for open house. These are low end fill 3D printed fillets. Those will be replaced with carbon fiber nylon for the actual flight, and the hardware will be flush mount. This is just protruding. We have some alternative hardware already here in the lab that we just need to swap it out with. And these will likely get either speed tape or some sort of cap put over the holes for drag reduction. So
Okay.
the paint needs rework.
So-
It's been tossed around in our cars for the last couple of weeks. So
And if you guys did a test flight, I'm expecting some beauty damage to the paint job.
absolutely, yeah. And we'll be
So is your
first test flight Memorial Day weekend, I believe, is the plan. We had to
Okay.
scrap the last one due to weather in Seymour.
oof, that's
Yeah.
rough.
Yeah.
So back to your nose cone, fiberglass SRAD or COTS tubing?
Cots. All cots. Yep.
COTS, okay. And the shoulder length going into the body tube looks more than 3 inches, which would be half the caliper of your body tube, which is
Well,
good.
it's 1.5, correct, on the body tube side because it's a plane of separation.
Oh, yes. If it's in separation, it's 1.5.
And so this is 9 inches, and it's I think it's
Awesome.
4 or 5 into the nose cone, which
Okay.
is fixed.
Which is perfectly fine because it's going to be mechanically screwed in, correct?
Yep.
Or
Yes, sir.
chemically mounted in.
Yeah. So it's got 4. Are these 1032s? Is that or no? They're
Those are
massive. Yeah, we've got 4 fairly large bolts that feed through the outside of the nose cone to hold into place the not only the ACS sled from moving whenever we have forces exerted on the canards, but also to hold that coupler in place. There's that ACS sled. Currently, it has Wagos on it. I understand the competition doesn't really like lever nuts or Wagos, just due to connection in flight. Those will be replaced with screw terminals. Considering
Okay.
this, if this system fails in flight, it could be a catastrophic failure. So we'll swap to screw terminals, and that's where that small lipo battery is. Or is that lipo?
No, this is a
That
small.
should be a lipo, it looks like.
Yeah.
That's a small lithium ion.
Lithium
one,
ion,
but
yeah.
it's-
So for the lithium ion, it will still need to be a cylindrical shell.
That's what I was talking about. This one will get replaced with a 18650 battery pack as well. Which 18650 pack in there? It's not.
No, I think the whole shebang is over there.
Is it? Okay.
Actually, I might have that.
Oh, I hope it's here. We have a battery pack. Yeah, we have a battery pack that we've already made for the ACS system.
Mhm.
I say ACS system. Oh, it's actually right here. I found it. So currently it's just a 3D printed core with these battery clips on the outside of it. And don't mind the Doc Ock mess on the top. But
You're
yeah.
fine.
So this is
I
oriented.
do suggest before you shove the ACS system mount inside the nose cone, put zip ties up and around the batteries to make sure they will not fall out in flight.
Okay, that's what I was thinking. Is we just run a zip tie around this, and it would keep them from being able to shift much, and they can't come out of the clips. So even if we have a disconnect, which, like I said, these clips are very solid. In order to get the batteries out, we have to use a flathead to compress the spring side of the clip.
Okay.
And I mean, even then, it's a substantial amount of force to get the batteries back out of it. So I think a disconnect in flight is a very low probability.
Okay, I know Astro likes to see redundancy, so I say at least 2 zip ties, one on the upper side, one on the lower side.
Okay, will do. Sadly, I know, just kind of on the electronics here a little bit, we have our ACS sled already pulled. If you want to continue working from the top down, we can do that. Or we can. That's our AV. Yeah, AV sled. Sorry. But if you want to continue working top down, we can do that. Or I can talk
Your
to that.
EV sled is your avionics sled, correct?
Correct. Our recovery. Yes, sir.
Okay, and what is your alternative you guys are using?
We have a Blue Raven and we have a Raven 3. Yep.
Okay.
Yep.
And their batteries are also going to be a lithium ion or
No, our
manufactured supplied LiPo.
9 volts each, which is recommended by them.
Yeah, recommended but not supplied. They're each just a 9 volt.
Okay, 9 volts are perfectly fine. Just make sure you put the connection side of the 9 volts in the positive axis of the thrust force, which would be the z-axis.
Okay, perfect. So make sure the connector isn't on the aft side.
Correct.
Okay, can do. And this is our old sled. It will have a second piece of all thread that runs through it for alignment while it's inside the body tube, so that we can insert the switch before it's installed in the rocket, so that we don't have active avionics while we're doing charge well filling. And luckily, all of our charge wells are accessible from outside the rocket. We recently had a rocket where we had people reaching their arm down inside it to try to position it correctly. While avionics have a pin in them, we have energetics in place, and I mean, I feel like that's way too much exposure to risk there. So,
yes.
But luckily, all of this is externally accessible, and the AV bay is standalone with a switch band, so there's no need for it to be installed in place before we can render it safe.
Okay. Awesome. And then what is your sleds made out of?
This is
PLA,
this is
ABS.
This one's a nylon CF.
Okay. Awesome.
And it's been temperature tested and no warping or anything.
Temperature tested to what degree?
The hot Wichita sun in a black body tube section.
Yeah, so it's sat. I think we had some other 3D print warping whenever we went out for our test flight. This was inside the AV bay in the rocket for we were out there for 5 hours or something, and it was in the sun the entire time, plus the setting in the car for weeks after that. So and no damage at all. So.
Okay. Because we are expecting the hottest summer this year in New Mexico at 115 during competition.
Okay, yeah. I was down there last summer, and I realized how hot it's going to be out there. That's why our payload is kind of ran the way that it is. Speaking of, we don't have the payload on hand. I'm supposed to receive a design document tomorrow from our payload team to review and approve them for ordering. So that's coming from the club side. The Jace, Jay, and I are senior design members that actually did the overall rocket design, but the club involvement is the payload this year, and We just haven't seen much movement on that side, so we're still working with them to get something functional in the rocket in a safe manner.
Okay, we'll talk more about the payload when we get to that section.
Sounds good.
Do you have the fins for your ACS system, your canards?
We don't. We're actually going to be milling them out of aluminum. We had some other ones made with composites and aluminum U-channel. However, we had some issues with edge distance that I didn't feel comfortable with in the manufacturing on the composites. So I decided that we were going to do a redesign and mill them just out of solid stock. Make them a little
Okay,
more.
and do you have the original prototype of the canards with you?
Oh, maybe. Let me check. It should be in the Tupperware container, maybe. Okay, yeah. It's fine. It's in the bag. So, yeah, pop that one out. Oh, there we go. So,
That one's a little bit misaligned.
yeah, it's that's part of that edge distance issue. So,
Okay.
the entire thing will be full milled, and it will have a hub on the back, and the front will be chamfered. So,
And we'll have a nice flange for mounting to the shaft
exactly,
extensions.
yeah, it'll be able to be mounted to the shaft extension quickly. Rather than this one, you have to take the canard out and access these bolts on the back side of it, and that's where we had that issue. Is the U channel's only so tall, and like you can't really get something that's slender enough to fit the material we're using and tall enough to prevent edge distance issues. So we decided that milling something will probably be a better quality product and something that's more structurally sound.
Okay. Really cute. I was kind of expecting something a little bit larger, but
Yeah,
if they work to
with
speed down
our
your rocket, it's good to go.
with our with the stability requirements of SAC being 1.5, we're kind of limited on aero surfaces. And originally we planned on doing pitch, yaw, and roll, and air braking. And so we needed them placed as far forward as possible from the CG to get the pitch and yaw control. However, we don't need that anymore because we've decided we're not doing pitch and yaw due to our altitude margin and just roll mitigation and air braking. So we could move them back further, but that's going to require a reanalysis of control interaction.
Okay. If I remember correctly, an ACS system was only allowed to help slow down the rocket. It wasn't able to help guide the rocket to a specific altitude.
Yeah, from what I understand, small perturbation correction and drag control were the two areas that you could use it in.
Okay.
Based off the design guide.
Mm-hmm. Awesome. Okay. And then I saw on your bulkhead for the nose cone, you're using wing nuts, correct?
Yes, sir. That's
Do
correct.
you plan on using Loctite on them?
We weren't originally, but we can.
Because a lot of safety reviewers, when you'll meet your group of safety reviewers for the in-person safety review, a lot of them will not allow you to fly with a wing nut because
Okay.
they do easily unscrew themselves in flight. If you're able to switch to a regular nut, that would be better.
Okay.
If not, mention you'll be using Loctite on your
Okay.
wing nut.
Sounds good. I don't think that would be a difficult thing to add in. We've already got Loctite for the fin can, just with it being removable hardware. We want to the risk of things shaking loose in flight, so we're going to apply temporary Loctite to the fin can as well. So to add it in a couple more places would not be a huge issue.
Okay. And if you don't want to buy Loctite, always just use hot glue the day of competition when you finalize the assembly of everything, and then before you launch it,
Okay.
it'll be fine too. Okay, so let's go down to your body tubes now.
Okay.
So it's fiberglass cut tubing as well.
Yes, sir.
What is the thickness of the tubes?
Oh, 0.08, I think, is the thickness. It's the standard wall
Okay.
thickness.
0.06, I think.
0.06?
Yeah, that's
7.9.
should be thick enough to have a safe flight with most competition rockets being CUTS tubing, so that's good. Actually, one quick question about the nose cone. Since your avionics bay are going to be in the nose cone, where will your pressure holes be located?
So this is actually not avionics in the nose cone. The AV is in the midpoint of the rocket. It's the separation coupler between the halves.
Oh, okay.
So this one is purely just the control side, and we
Mhm.
do have the recovery bulkhead on the aft side, but the wires run up through the fore section of the rocket through the payload bay to trigger these recovery.
Okay, just double checking. 'Cause I don't,
Of course.
we don't need an issue where there's no pressure vent holes and or deployment of the main, I'm assuming, on the forward end of your rocket would not deploy.
The drogue is actually our four chamber, so we're going to deploy the. I believe this is. Am I wrong?
Yes.
I might have it backwards. This is something that I've looked at like 600 times, and I always get it backwards. I always have to think about the deployment order and how we fire them.
I know most teams I've seen, and I usually fly my drogue towards the aft end, and then main deploys on the upper sections.
That sounds right because I think the nose cone comes off last. I think that's
Okay.
correct. Yeah. Yeah, that sounds right.
You're, that's fine. Perfectly awesome. And then does all your separating tubes and nose cone have your team number and your frequency on the rocket
Not
body?
currently. So we plan to add the required team numbering above the fins on the aft section. And then we will add the team number and frequency on the inside of each of the separating sections.
Okay, 'cause I believe this year they want the frequency on the outside of the rocket.
Okay, sounds good.
So if you guys have a label maker, when you do get your frequencies at the convention center from Da Vinci, just slap on a quick label sticker onto your rocket and you can peel it off after competition.
If we're using like LoRa for our telemetry and GPS tracking, should we just put like our 915 megahertz on the side or something, or our LoRa communication settings?
Can you repeat that? It was hard to hear you.
Yep. If we're using LoRa for our telemetry and GPS tracking, should we just put like 915 megahertz on the side, or?
Um, just in case, yes,
Okay.
but even with your own like tracking station, Da Vinci would need to know your or will need to know that as well. And they may have to assign you a different frequency.
Okay. With
That's
with our
why we
system,
required it to be an easily changeable frequency for any tracking.
I think someone on the Hero X forum mentioned that they were adding LoRa to their receiver bank this year, but we didn't need to connect with them if we could verify that we have GPS tracking with our own ground station. But I'll email them with our current setup and make sure that
Make sure that that's good before we
Yeah.
go to launch.
Okay, that's perfectly fine. I know usually we like to have Da Vinci also locked in onto your rocket's tracking, so they could also track your rockets. Last year we had the first time having last known positions of rockets, so people would quickly look on the map to see the rough estimate of their rocket's position last known before it would pass the horizon and touch down.
Yep.
Just in case your telemetry system So your ground station does malfunction in flight.
Just want to make sure that there's a second lock. Yeah.
Yeah. So how many body tubes do you guys have that's connecting the whole entire rocket?
So we have 2 body tubes,
Okay.
4-foot sections. So you got the
So
aft
the
side.
white one is your upper section and the yellow is your aft section. Okay.
Yep.
Awesome. And then in the white body tube, what will be located in that tube?
Yeah, so the payload bay sits in just about the center of it, and the payload bay
Okay.
is up there on the table. So we can review that in a minute if you'd like. But the payload bay sits in the 4 section. Then we have nose cone, or sorry, in the center of the 4 section. We have the nose cone connection. So it'll set down probably, 9 inches inside the tube. And then we have a recovery bay. Payloads behind that. And then we have the foreside of the AV bay. Sorry, keep a track of the camera.
Okay.
So AV bay backs up to the payload bay to recovery, and then recovery to nose cone.
And then for your nose cone connection points on that tube and your upper av bay attachment points, what will you guys be using to attach them to the rocket?
I believe we're using 440 shear pins, if I remember right. Jay, you can hop in on that if you.
Yep, you're right.
Okay, cool. 440.
Awesome. Okay. And then what set of black powder charges are you using for both separation points?
Oh, Jay, do you know that off the top of your head? I think the foreside was 4 grams and aft was 6. If I remember right.
That sounds right. It might be 5 and 6, but 4 or 5 on the 4, and then 6 on the aft.
Yep, I believe that's what we tested with. That sounds correct.
Okay, so that sounds pretty reasonable for a 6-inch rocket diameter. Just for redundancy, your primary should be what you tested with. Your secondary backup charges should be at least 1 gram or 2 more, just in case the primary charge did not deploy the separation.
Okay, sounds good.
Awesome. And then what will be I'm sorry.
All good.
Well, what mechanical screws will be holding the payload in the bay
It is,
without shifting?
yeah, the same for. Are these 1032s? What are these? They're not quarter 20. They're too small for that. Oh, 3/16s. I think they're 1032s. 1032s,
Okay.
a lot smaller. Yeah, 4 of these bolts. They're fairly large.
And it will be 4 on the upper section and the bottom section of the payload, or just 4 in total?
4 in total, center located inside the payload bay.
Okay. If you are able to, 4 is going to be very little for a 9-pound
Okay.
payload for most safety reviewers' liking. I
Okay.
suggest at least probably doing 6 minimum
Okay. Sounds good.
centrally. Next year I would suggest doing a forward end and a bottom end of your payload mounting with 4 each
Okay.
for redundancy.
Sounds good. And that wouldn't be an issue for us to add another ring even of fasteners at this point. We could do that to
Okay.
have a total of 8 with 2 rings.
And then for your payload, what will your payload be?
Yeah, so the payload is an expanding gas cooler. Basically, it will sit inside this bay, and flipping my phone around. It will have a compressed bottle, I believe, of CO2. That'll be a COTS pressure vessel, and it will expand that CO2 through a line with a servo, or not with servo. and the goal is just to cool the payload bay internally. Because of some of the restrictions on the competition, we figured that we couldn't route the cool air through the other chambers because the payload needs to be non-essential to the flight of the rocket, from what we understand. So it'll just cool internally inside the bay.
Okay. And then, so it's also going to be a fiberglass COTS shell.
Yes.
Is it going to be attached? It's going to be permanently attached to the rocket for flight. It won't be deployable, which is awesome to hear. Not the biggest fan of a deployable payload myself.
There's always a bunch of mess that goes along with that. So we were going, but then there was a restriction that was applied. We were going to do a drone, but that's just because we had a competition going on at the same time with the university for a drone. So we were going to look for a deployable form factor.
Oh, okay.
So it was
Well,
kind
the
of
good news is for next year, Astro's already decided we will no longer be accepting a deployable payload. Everything will have to be fixed inside the rocket for the whole entire flight.
okay.
So
It's a little
just
safer.
yes, after we had several issues last year with deployable payloads, and we'll talk more about that when we talk about safety at competition.
Sounds good.
Any altimeters or GPSs in the payload?
Nope.
Okay. And then the hardware or the electronics for your payload. What type of batteries will be powering the payload?
Those will be 18650s as well, from what I understand.
Okay.
I'm expecting a payload design report tomorrow from the payload team, and anything that doesn't meet the D tag, I'll make sure I let them know and request a revision early in this next week. So we'll have ordering done this week.
Can you also keep me updated on the payload progress?
And I can
So if
send
you
you
want-
whatever report I see as well, so that you're familiar with what we're doing. And as soon as we have a functional model built, I will work with you to do a review of that if you'd like.
Okay. I should be fine since it's not gonna be since it's gonna be internally mounted and not being deployed
Of
and
course.
has nothing to do with the rocket's flight. I should be fine. Just remember we're 30 days away from competition. June 18th would be the poster day, so
Yep.
it's a very quick timeline to get that payload built. If you're unable to build it in time, I just suggest having a boilerplate payload, which is pretty much a mass weight of
That's what
8.8
we have
pounds
here.
or more.
Test flight is 10-pound ballast.
What was that?
Currently, that's what we have in here is a 10-pound ballast for test flight.
Okay.
So we're able to fly the rocket before the payload team finishes up with their design.
Okay. So they're unable to finish up their design and build it in time for competition, just fly the ballast weight.
Okay, sounds good.
Just to meet that 8.8 requirement to get the points.
Will do.
And then let's go talk about your other coupler, your avionics bay.
So it is two different links with a switch band, one 9-inch and one 6-inch section.
Okay, awesome. And the 6-inch section will be sitting inside your motor tube for your motor section, correct?
The 6-inch will actually be in the fore section since our aft side is separating. The fore side is fixed.
Oh, okay. And that'll be permanently mounted with, I'm assuming, 4 1032 screws as well.
I believe so.
And are you planning on using like what are they called? Key certs or hex or
The captive nuts.
no my job we use a lot of king or key certs. Helicoils. My rocket team would use helicoils to make sure screws were properly fastened inside the rocket and not wiggle out.
planning on it, but I can definitely look into it and see if that's something that we can incorporate.
Or if not, if you're able to access it and put a nut behind it.
Yep,
I know
we
usually
access the AV bay on installation. So we put the fixed side in and leave the aft bulkhead off.
okay.
And are able to reach up in there and hold the nut in place while we put the fastener through. And then we put that aft
Okay, so if
bulkhead
you're
on.
able to mechanically lock the bolts in, perfect.
Absolutely.
And then I'm assuming the wall thickness is also 0.08.
I believe so.
Okay. And then also using four 440 shear pins
On the aft side, correct.
aft end. Okay. And then I see looks like you have pressure vent holes in your switch band already.
Yep. There are 4 quarter-inch, I believe.
4 quarter-inch, okay.
Yeah, and that's off of suggestion of mentors for the quantity and size of the holes for the size of the rocket.
Mm-hmm. Awesome. And then what type of switching or what type of switches will you be using to arm your avionics?
Yeah, so we're using, I think it's, what is it called, Rat Labs or Lab Rats, something like that. The pull
Oh,
pins
you have a pull pin. Okay. I like pull pins because they're very easy and convenient to just pull them out on the launch rail.
Absolutely. I think magnetic might be my favorite type, but the pull pins are always very simple.
Mm-hmm. I know last year we did have a team having issues with their magnetic switch.
Absolutely.
I kind of like a mechanical switch to know once you
Yep.
pull it or switch it to the on position, it will
Absolutely.
stay on, and you visually verify it will be on as well.
Absolutely.
And then okay, can I see your avionics sled?
Yeah, so this is it right here.
Oh,
This
that's
is
it. Okay.
this is our current design. This is just what we have in here right now for we had it for open house display purposes to hold all the electronics and everything and for recovery testing. This one sadly swivels inside the rocket, and that's an issue with orienting the pin. So we will put a second piece of all thread through in order to lock this in place and orient it with the switch pin.
Okay. Awesome. And then your recovery connection points. Looks like you're using U-bolts, correct?
Yes, sir.
Make sure to have the U-bolts locked in with Loctite as well to make sure they will also possibly unravel in flight and detach from the rocket in the recovery phase.
Sounds good.
And then let's look at your aft section now.
Okay.
So we know the body tube is fiberglass cots, but the fin is carbon fiber SRAD or carbon fiber cots as well.
Cots as well.
Okay. And you guys are using exterior mounting.
So they pass all the way through to the motor mount. The motor mount is an aluminum, I guess, full setup on the aft end. I think I've sent you a model of it before.
Yes.
Where it's an integrated thrust plate with full length uprights for the fins. And then we have a centering ring. And so we have full contact with the body tube and the motor mount tube for the aft, like 10 inches of the rocket, I believe. So we do not have a forward centering ring, but we are full contact for that entire distance.
Okay. And you're not doing a tip-to-tip section because the mechanical fillets, which is
Correct.
perfectly fine.
And mechanical fillets are both riveted and bonded to the body tubes.
Okay. And then you're using, looks like a total of 4 mechanical screws to connect your fins to the body tube,
Yep, so 4 quarter
or
20s.
your fillets at least.
Yeah, 4 quarter 20s externally to attach it to the body tube per fin, And then the fins are attached with 6 M4s internally per fin.
Okay. And then can you lay the motor aft section on the ground?
Yeah. Will you tip this over? Just motor mount towards me. Yeah. So
I would like you, most teams hate this test, push down on the fins as much as you can.
Oh, this is going to suck. Let me get it in a position that I'm not
The
going to break
whole
anything
point of
else.
this test is to see if your fins will flex with
Yeah,
as much force as you can apply.
Yeah, I'm leaning on it.
And if I could actually have the camera a little further back to see if you could
Yeah, Jason,
flex those fins.
Give it a push and show him the flexure.
Like push down with all your might. Yeah, they're not moving.
Yeah, they're in there. So if they flex, we're bending aluminum in like 3 places. So
Twin floater is at least one.
yeah, and they're fairly thick as well. They're not.
Yeah.
They're 3/16.
Yes.
Yeah. So,
Okay. Awesome. And then your motor tube is aluminum, you said, correct?
our actual motor tube is phenolic, but it has full length
Phenolic.
with the aluminum all the way to the front of the fins.
Okay. That should be fine. You said 4 centering rings. What are the thickness of the centering rings?
So we have the thrust plate integrated centering ring. That's, fairly small. It's just a lip that sits on the inside of the body tube here.
Mm-hmm.
And then we have a forward centering ring that is 1/8 inch. I think it's 1/8 inch water jetted aluminum. But we also have 1/8 inch runners that run the full length of the fillet that also contact, so they act as centering rings on this aft section.
Okay. And your thrust ring will also be the motor retention point, correct?
Correct, and that's what these holes are for. We have captive studs that go in here and a aluminum water jetted retaining plate that is, I think it's 1/4 inch. It's a 1/4 inch retaining plate. So it's got 3 ears on it that line up with this. Okay, there it is.
Okay.
And that
like
sets
that. So it's gonna be mechanically locked into place for flight, correct?
correct. Yep. So that'll have Loctite on it as well.
Okay. I don't know how Loctite work or the temperature rating for Loctite's use.
Okay.
Your motor gets really, really hot really quickly.
Yep. And with this being aluminum, the thermal conductivity is going to be pretty high.
Okay. So just
so we can swap lock instead of Loctite if we need.
That one's gonna melt too.
Yeah.
I personally don't have an issue with it, but other safety reviewers, we all have our own opinions on rocketry because you do everything so different in rocketry. They might not like it and will make you change that.
Okay.
So just be prepared for other different opinions on rocketry when you get to the convention center.
Of course.
Your in-person safety review will be your final go or no-go decision from them.
Okay.
So just be prepared for any questions they have regarding the whole entire rocket.
And so here, what we have is we have 3 per all thread that or captive stud that we put in here. We have 2 fasteners to hold it in place on the thrust plate side, and then we have 1 on the side of the retaining ring. I'm just worried about that aft one being able to loosen off and that thrust plate come off, even though there's quite a bit of an interference with it between the other threads. But that's my only concern is like we might lose a nut off it if there's not something in the way. So if we put either nylock or doing Loctite, it would just be to, retain that nut. I'm not worried about losing the motor or anything like that.
Okay. Yeah, just let your safety reviewers who are going to be reviewing your rocket, I might be part of that, depending on what table you get in the convention center.
Okay.
So, just be prepared for questions that other reviewers will have. And you guys looks like won't have a boat tail, which I prefer no boat tail.
It hurts your stability. We're trying to put canards on the thing, so
Yeah. Well,
yeah.
you could always design, or my team would always design a rocket around the motor that we decided to choose for that year.
Yeah, and this year in M2000, like we had 4 M2000s already at the club, so we were like, okay,
Oh, wow.
M2000 probably what we're gonna go with.
Yep.
And we kind of worked back a little bit from that. We kind of sat in that motor range. I think we did order one in 2500, something like that, because they were out of stock on the 2000s, and a little extra thrust doesn't hurt us. So we've got
Okay,
one
that's
of those,
fine.
I think.
And I've learned usually if your rocket design that you already have has gone below the minimum stability for ESRA, you can always usually add weight to the nose cone to
Yep,
help add stability too.
of course.
That's what I've learned with my own level 3 rocket. I had to add like 4 pounds to my nose cone to make sure it was stable in flight.
Dang, yeah. We were a little worried about a dumbbelling effect with high-end mass distribution. So, you have your motor that's a high amount of your mass, and then if you put a ton of mass up in the nose cone, you can get some dumbbelling dynamics. But and that's just something we're looking out for, given our active control. We want to make sure we don't enter some weird dynamic mode and end up spiraling off.
Oh, that's very true as well. Okay, so that looks about it. You guys have built an M2000 before, correct?
Yes, sir. We have one built currently for test flight.
Awesome.
And we worked with one of our other mentors to construct one for the first time. I think the team, one of us had built a high power motor of this size, a level 3 motor. I think Kyle was the only one who had built one, and he's not here today. But one of our club mentors helped us to assemble the M2000.
Okay. So at least you guys have some experience with building a high power motor. I'm pretty sure Steve is also really well known with also building motors too. If you guys have questions,
Thank
you'll always ask Steve.
Does his own propellant, so unless we're flying his
Oh,
motor.
even better. So he knows the issues.
Yep.
So let's talk about recovery. What
Okay.
type of shock cords are you guys using?
We are using tubular Kevlar.
Tubular Kevlar, okay?
Yep.
What is the length and thickness of them?
I believe it is 30 foot per section.
Okay.
And then I think it's about ½ inch. It might be 10 mil
Okay.
is the webbing size.
How will your team prevent cord from snapping with the snatch force of the Kevlar?
That's a good question. It wasn't really something that we have analyzed at this point. Originally, we were going with 20 mil nylon flat webbing, and we upgraded to the Kevlar, having flown other rockets on the Kevlar, larger rockets, or I guess probably about this size. And I mean, they were flown successfully, and I think the shock cord might be a little short, but we can always chain together 2 sections to reduce the shock force and allow more distance for dissipation. that could be one method for reducing the force in the cord.
Okay. You can also always braid your shock cord in like a I forgot what the braiding is called. Another team that I reviewed yesterday is also using that method, where it's pretty much one giant slip knot braid. So when it does eject, it will be braided through, so it won't have such a gigantic snatch force in the
Okay.
Kevlar.
Yeah.
You can also use a bungee cord to absorb the shock of the deployment as well.
Okay.
Um,
So incorporating
I
elastic.
haven't. Yes, with the just the elastic to pretty much absorb the shock, and it eventually will snap off in flight. But you'll have your Kevlar shock cord to technically hold everything still together on drogue or main.
Okay.
I personally have never used Kevlar shock cord. I always use tubular nylon
Okay.
because it has more of that extra give and stretch
Of course.
that Kevlar doesn't have. So just keep that in mind. Because safety reviewers will ask about these snatch forces again at the convention center in Las Cruces.
Okay.
So be prepared for that question as well. And then for the shock cord, you guys know about the 1/3 rule of the shock cord for your parachute location.
Yeah. For distribution parachutes, yes.
Yes. And I do see you using a parachute bag for your main parachute, and it looks like a Nomex blanket for your drogue.
The drogue is not over here right now, but yes, the drogue does have Nomex. I think this is it over here. So the drogue is fairly small. It's just I think a 2-foot drogue.
Yeah, 24-inch. That's a 24 or 36 is usually the drogue that we usually see for competition.
Yep.
And it's blue and white, which is good. And your main look like it was red and white.
Actually, I think it's yellow and orange. Yep, yellow and orange.
Okay.
So we do have red and white of the same size, same CD as well. So we can fly either one.
Okay, and are you using a pilot chute to also open up the main?
Correct. There's a pilot chute on the deployment bag.
Okay.
It's just a 1 foot. It might be a 20-inch.
Okay. So your deployment bag will not be mechanically fixed inside the body tube. It will just deploy with the shock cord.
Correct.
Okay. What is the descent rate for the drogue and main?
Descent for the drogue is 75, I want to say.
Okay.
Oh, yeah. Let me open rocket really quick and we can.
Yeah, we're looking between anything between 65 and 100 feet per second.
I've got it open right here. It looks like it's 82 for the drogue.
That's velocity at deployment.
Yep.
Oh, yeah.
And I don't think the main has been updated in this model. Let me update it. We increased the size of the main. We had misread some guidance on the D-tag or a requirement for chute sizing.
Okay.
Or descent rate, sorry. And so we were descending fairly quickly. We are at 25 under main.
Okay. Yeah, main would be under 36 feet per second.
Yeah, and I think we were at 35 on a 5-foot main. So we upsized to a 6-foot and went down to 26.
Okay. And a 6-foot is a
72-inch.
60-inch parachute? No, 72-inch.
72. Yep.
Okay. Oh, For my personal liking, I think that's a little too small. I know with my 5-inch, 7-foot level 3 rocket, I use a 96-inch parachute.
Was it a 0.8 or was it a 2.2?
I don't remember. It was my old team parachute that had like a few burn holes in it and they wouldn't use it anymore. So I said, I'm not gonna buy my own parachute. I'll just reuse that parachute.
Yeah. So we are flying a 2.2 CD chute from Rouse Tech. So
Okay.
it's drag coefficient.
I know we always bought our shoots from Fruity Shoots.
Yeah, so they have some chutes. I think they were the original ones to do the 2.2 CD. So yeah, I mean it's very possible that it was a 2.2. But
Okay.
we have larger chutes. I think we can fly with up to. I mean, we've got a 192-inch one that, if we're really worried about descent rate, that
Yeah.
we can
Well,
get
if you guys
us.
are comfortable with 25 feet per second, that's good for you guys.
Yeah, I think our
With
fin
my
can.
personal liking, I want a little slower for main,
Okay.
so you don't have such a hard impact force on the ground. And then hardware on the shock cords. You guys using quick links, swivel links, with the quick links?
Quick links, and then each of our parachutes has a swivel at the attachment point.
Okay. Awesome. And then what will be the aft attachment point for your lower parachute, which I'm
The
assuming will be your drone?
yeah, forward closure of the motor,
Okay.
and that'll be a closed.
Make sure the eye bolt on your forward closure of your motor casing is torqued down so it won't unravel itself in flight.
Absolutely, we're putting a jam nut on it as well. So
Okay.
jam nut into it, and we actually are unable to get the eye bolt off as is. It is on there, so we're gonna have to take it off to replace it with a closed loop eye bolt per the DTEG requirements. But
Yep.
that is something that we need to do.
Okay. And as a like redundancy for safety measures, as for really loves redundancy, you can always add a quick swivel link at that attachment point too to make sure it won't unravel or unscrew itself under deployment as well.
Of course. Are there any recommendations for swivel connects? All of them that I've seen have been low weight or non-load bearing swivels. Do you have a suggestion for brand or anything like that, or where to get swivel links for loading? Just
Um,
really high loading
so
point.
my old team is just buy our silver links like from Home Depot.
Okay, sounds good.
Would buy like a really one of the larger swivel links and quick links. Look at your quick links there on the foam. Those may be a little bit too small for Esser's liking. They might require a thicker one.
Right, sounds good. We can increase that.
Yeah. So it shouldn't be too expensive. Just replace those with a bigger and thicker quick link. Okay. So everything with your rocket looks good. Just, the safety review is done, but I still have more stuff to talk about regarding competition to you
Okay.
guys. If you want to stop the recording, you can
Sounds
at
good.
this point.
I am going to also move over to the laptop so we can hear you a little better and everything.
Okay.
And I'll stop the record.
Let me Is there not a? I've never used Microsoft Teams meetings before.